it's a great pleasure to be here to talk among developers, so thanks for having me here. I'm going to talk about something that we all work with every single day. If you really think about what we do when we go to work, we deal with complexity every single day. Some of us create complexity every single day. And so that's what I want to talk about, simplicity, which is the opposite of complexity. Well, I travel a lot. I travel about 250,000 miles a year. And recently I was sitting on an airplane when a guy next to me wanted to give a small talk, and he said, "What do you do for a living?" I said, "I'm a programmer." He said, "Well, that's the easiest job on earth." I said, "Well, that's great. Somebody thinks so. But can you tell me why it's the easiest job on earth?" He said, "Because all that you have to know is zeros and ones." I said, "Well, you're absolutely right, but do you know why they pay me the big price for it?" And he was very curious. He said, "Why?" And I said, "Because only we know how to put them in the right sequence." So we deal with complexity every single day. I want to look at one thing we have in this room, and I want to trade the word complexity with something else, which is capability. And the human brain is probably one of the most capable things we can ever imagine. And if you really think about the human mind, we can come up with stuff that just amazes over and over and over. We can't quite define where innovation comes from. How many times have you looked at something and said, "How in the world did you think of that?" And we just say, "It just came to me." And so the human mind is probably one of the most capable things we can ever imagine. And at the same time, though, there is something weird about the human mind. We also get very greatly affected by emotions. And we get tangled into emotions, we get into analysis paralysis, and we have to deal with it. So it's the most creative mind, after all, that causes trouble for us as well. And so when you look at complexity, if you really ask me, what do I do these days? Well, I would say for the past about 5 to 6 years, I can tell you, for most part, what I do is I work in companies where I work towards removing complexity. So when I walk into companies, yes, please. So one of the things that we deal with every single day, I said, is complexity. And if I really think about what I do for a living, is I walk into companies, and when I leave, they tend to really remove a lot of code. So I'm in the code removing business rather than code writing business. And I try to really help complexity, remove complexity on a daily basis. But if you think about the complexity we deal with every single day, the question to ask is, why do we really deal with such complexity? Where do those complexities come from? So I want to talk about the so-called art of simplicity and how can we make things simple. Well, I've got 2 children, and a lot of times dinner conversation for us is to talk about something a little geeky. And it's often that we would talk about the so-called Schrodinger's cat. And Schrodinger, back in time, had a mental experiment, and he said there's a box, you can't see through it, you can hear through it, and there's a vial in the box, and he said that there's a cat locked up in the box, and his argument was at any given time, the cat is both alive and dead. And how do you really conceptualize some of these things? When you think about it, it seems really weird, really complex when we think about such kind of issues. But every single day, we have these kinds of conundrums that we deal with. Every day, every single day in our own jobs, we deal with them as well. But I want to really think about complexity. And Confucius said, life is really simple, but we insist on making it complicated. And there are 2 kinds of people, I would say. Some people who take complex things and make it simple. There are other people who will take simple things and make it more complex. Maybe there's a 3rd category who will take complex things and make it even more complicated. And we deal with all of this, but the first question I want to start with is the question, why? Why do we really deal with complexity? And I've been thinking about this for a while, and I think I have a few answers why we deal with complexity every single day. And one of the reasons is, let's be honest about it, it feels really good when you create something complex. Be honest. Isn't that true? You create something really complex and you feel quite happy doing it. You go to your colleague and say, "Here's the design," and your colleague looks at your design and says, "Yeah, that's simple," and you feel let down. You say, "Give it back to me. I'll come back tomorrow," right? And the next day you go back and show your design, and your colleague scratches his head and says, "I don't get it." And you're like, "Yeah, it took me a few hours to create it. you at least take a few minutes to figure this out. So it feels good when you create complexity. The second reason is you feel you're important when you create something complex. If you create something simple, you feel that people won't respect you, right? So we feel that we have to really create complexity to feel that we are important. You probably hire an intern to come and work in a company. And the intern finishes the summer job, goes back to campus and says, the company I work with, these guys are awesome. These guys are wonderful. Because I looked at what they do, I don't have a clue what they're doing, right? So we feel like we are really doing great if we create something really complex, and that feels good as well. So there is a bit of a sense that maybe simplicity is not our worthwhile, we should really make things complex. But it really takes effort to move in the opposite direction. As Einstein said, any intelligent fool can create something complex and violent. But it takes a total genius and a lot of courage, and I want to underline the word courage, to move in the opposite direction. And it really is because when you create something simple, one of the problems you're going to face is you might be ridiculed for creating something simple. And people would fight you to it. People would ridicule you and say, what do you mean? This doesn't really look that really useful. This doesn't look important. This doesn't look interesting. And so we are forced to really clutter things up so that it can look important. But it takes a lot of courage, and he says it's a touch of genius because it turns out creating something simple is, after all, not that simple or easy. It takes a lot of effort, but a lot more courage to really stand up and say, I'm going to defend against this and really make this simple because it solves the problem. So the question to ask is, if you are sitting in a bus, and if Mr. Simple was sitting next to you, would you even recognize it? Would you be able to see that, oh, that's simple? And in fact, this has been really bothering me because a lot of us would quite quickly say, oh, we got to make things simple. But it turns out most of us do not really have a clue what really simple actually means. I was working with a group of developers recently, and I was complaining that a particular piece of code was very complex. And about 10 minutes later, one of the developers, gathered up the courage to say, hey, wait a minute, why are you complaining that this code is really complex? We all collectively think that this is simple. And I got really upset. I said, come on, you look at this and you say this is simple? And they said, yeah, it is. I said, explain to me why this code is simple. And one of the guys said, look at the code. All that you see there is a simple if statement. And that's when it dawned on me that they don't even know what simple versus complex really means. And we struggle with this all the time. Because the code I was complaining about had about 6 lines of an if and else statement repeated about 60 times. And the complexity comes from duplication of the code. And so the effort to maintain it is very, very high. And that really didn't come across because all that they could look at was the construct that was in there was relatively simple. And we get into this kind of problem all the time. So we all know that we want to create something simple. But how do we know what we are creating is actually simple? Well, that seems to be really, really hard for us to really understand. So I want to talk about how to make things simple. But it turns out that it really is not easy to say what simple is or even how to create it. So I decided to go in the opposite direction. What if I can point to you about things that are not simple and say, that one is not simple, that's not simple, that's not simple, and maybe if you can eliminate things that are not simple, maybe what we'll be left with is probably simple. How about that? So let's talk about what's not simple. And I want to start out by identifying a few things that we can clearly see as not being simple. Well, the very first thing I want to start with is, simple is not clever. Now, we all are developers, and we all are proud of developing, but one place where that pride kind of crosses the line is when we want to make things very clever. And that's ingrained in every single one of us. We want to create clever solutions. Why? Because it feels good to create clever solutions. If we are proud of the fact that we can go share to other people and say, isn't that cool that I created it? And so we all have this tendency to create something very clever. Well, I remember clearly one day, I was working at my desk when I got a call and they said that something has gone wrong and I need to fix it. And I looked at the problem, and I only needed about 10 minutes to fix this problem. And I looked at it and I said, I could spend 10 minutes and fix this, but why would I want to fix this problem? I want to fix the mother of all problems. And it would take me only 15 minutes to do it. And I took another 5 minutes and I solved what I call as the mother of all problems. And I remember very clearly when I finished it, my proverbial hand came and patted me on the back and said, Venkat, you are that good. You don't want to be solving problems. You want to be solving problems for eternity. And it felt so good that I didn't solve the problem on hand. I solved this meta problem. Well, 3 months went by. I got a call from production saying something terrible has happened in production. I looked at the problem. Within minutes, I told them, I can fix it. And they said, we know you can fix it because you are that good. I said, no, I can fix it not because I'm good. I can fix it because I caused it. And the problem I had caused, the clever solution I implemented, had backfired. So what did I do? I quietly rolled back my change and put back that one change that I had in the mind in the first place that solved the exact problem. And it's been about 6 years. No problem at all in production. So that's one thing I learned the hard way, is when you try to be very clever, our emotions kick in. And we are more interested in being clever than really solving the problem we have in front of us. So the lesson I learned from that day, now what I do is when I sit down and write code, the minute I think this is clever, I delete the code. And I start over and I solve the problem I really need to solve. And that is something we need to be very careful about. So cleverness is not something that we need to really encourage. We really need to focus on solving problems we understand. And that is something we have to really train our minds to do because, again, it's an emotional thing. We kind of get into that and say, I want to solve something very clever. Well, let's take a look at this for a minute. This is actually enum in Java. If you open up Java and take a look at it, that's what it's going to be. And it says public class enum E extends enum E. Now, just take a look at that for a minute. Well, that little noise you just heard, that's your brain throwing a Stack Overflow exception. And that is a sign of enormous amount of complexity built into the code. That actually code is working code. It's not an error. And whoever wrote it was extremely clever. And you can call them and ask them what it does, and they'll tell you, be quiet. And they would stare at it for several minutes. And then it'll come back to their mind and say, that's what it does. Ask them 5 minutes later, they have to stare at it again. That's a sign of very clever code. Now, I work with a lot of different companies, and they would come to me and say, hey, how do we obfuscate our code? Because we don't want anybody to steal our code. And I always ask them, why do you need something to obfuscate your code? Because your programmers already write naturally self-obfuscated code. They themselves cannot understand the code they write 2 weeks from now. So there is no need for obfuscation technology at all because we write self-obfuscated code. You come back from a vacation, you have no clue what code you're looking at, right? And so we tend to write these kind of code very often. But as programmers, we have this tendency to write code that very few people can understand. In fact, people take pride in writing code that nobody else can understand. Because if somebody were to look at the code and understand it, you feel let down, right? So I came across this piece of code, and when you look at this code, well, let's think about what this code is saying. Well, it says in square root, and it says float x. I don't have a clue what x is, but here's the good news. Whatever x is, we got a half of it now. So we have an x half. Now, then comes across the next line, which is wonderful. Don't tell me you don't understand this. This should be very obvious because it says star in star ampersand x. And how many times you come across code like this? Way too often. And if you complain about this code, programmers would often respond back saying, oh, no, don't worry about it. We can take care of it. We'll document it. And then what do? Then you come across code like this. You probably see I++, and you tell you don't understand why. And they very promptly, they say increment. And you're like, thank you very much. I was not sure, right? And just thanks for confirming it's actually increment. Or you see a code that says like this, and then very nicely there's a comment that says shift. These are not called documentation. These are called, let's insult the programmers. Because we don't have a clue why this code is doing these things. And the code is telling you absolutely the obvious in this case. We don't have a clue why this code even exists in place. Well, when you look at code like this, then you move on a little bit further. And what does that say? There is another very complex line. It does something, whatever that could be. And then it goes on and on and on. And then comes the most wonderful thing you can imagine. You got an X as an input, and you promptly returned X. So when you look at a code like this, how do you really comprehend? And imagine you are the person who is in charge of fixing a bug in this code. What's the title of the person who should fix a bug in this code? Not a programmer. They're called victims. And we all are victims of our profession, right? We just struggle every single day working with this code. Now, one of the problems in a lot of code we write is variable names. It is a well-known fact. The most difficult thing for a programmer to ever do is to name variables. Now, I can tell you for sure about this from my own experience. It's way easy to name children, but it's extremely hard to name variables. When my wonderful wife came to me and said, hey, we want a name for the children. Instantaneous. Here's the name. She's like, really? Absolutely. Now, please leave me alone. I got to think of the name for this variable now, right? So this happens all the time. We find it incredibly hard to name variables, but variable names represent abstraction. We have to really give a lot of importance to it. But how many times you see people give variable names so loosely, naming variables X, Y, Z, and P? Now, think about this for a minute. What does a variable named P actually mean? It means absolutely nothing to the reader of the code. Now, would you ever do this? Would you name your children P? They look at you and say, son, what's your name? P? Is that your initial? No, that's my full name. Oh my gosh, your parents would have been programmers then, right? So the point is, we don't give names like that. We give names that are a reflection of some abstraction, some concept, some idea, something that there's a context to it. And when we give variable names, that's exactly what we need to do. So one way to reduce complexity in code is to give good variable names. I'm not suggesting long variable names, but really good variable names. And it's impossible for us to come up with that in the first instant, but it's well worth trying and trying and trying. Well, then comes along a few other things we get into. Remember how they told us that object-oriented programming represents the real world? Well, be very careful with those things because one guy took it deep down in his heart. He was writing the flight simulator and said, really, the code represents the model of the real world, and he coded this. How do you deal with code like this? Now, if you are the person who's supposed to maintain this code, another victim at work, and how could you really, somebody should have looked at it and said, stop, take a break, right? Take a break. You don't need to work the rest of the day, right? Somebody should have stopped it. How could this code get checked into a version control, right? So that is something to think about where complexity brews in code. So I said that simple is not clever, but simple is also not necessarily familiar. We confuse this word very, very often. We always look at the word familiar, but we often learn the word simple instead of using the word familiar. And it helps to really stop and ask ourselves, is this something that's really familiar, or is this something really complex or simple? Because they're not one and the same. And we also, as human beings, have this tendency to associate what we are not familiar with to be complex. And that's just the human nature. And I see people say this repeatedly. They'll look at something and say, oh my gosh, that's complex. I'll say, how could you say this is complex? This is one of the most simple things. And eventually what they really identify is, I'm not familiar with this. So we get to associate what we are not familiar with something that's complex. And by really identifying that and putting words into that, we can help to really identify whether something is really complex or something that might actually be simple, but we are not just familiar with it. Let's look at some examples of this. Well, can somebody tell me what this means? Nobody? Chinese in the audience? There's nobody who knows Chinese here? Well, okay. Well, this actually is a word that stands for these things. Simple, uncomplicated, casual, common. How do I know? I Googled for it. So it's got to be true. So the point really is, most of us would look at this and say, oh my gosh, I don't have a clue. That looks really complex. But a large population of the world, for them this is very common. This is very trivial. They see this every single day. So when you travel around the world, you might come across language that you're not familiar with. I spent a good part of my time in different parts of Europe. And I would look at the signs on the road, the words everywhere, and I would always look at this and say, I don't understand any of these. But it would be foolish of me to say these things are complex because I don't understand it. A good population lives there every day using those symbols and signs and words. It's just that I'm not familiar with it. So it's important for us to distinguish between what is unfamiliar versus what could be simple or complex. Let's look at some examples of this. Let's say I want to total the price discounted 10% of certain values. So I want to say here are some price values that I have on my hand, and I want to total these values, but I want to discount them by 10% and print the total. So I'm going to use JavaScript here because it doesn't matter what language you're programming in today, you're programming in JavaScript. So I'm going to say, result here total is equal to 0, but I want to take each of the price and total them with a discount value. So what would I do? I would say var I equal to 0 to begin with, I less than prices dot. Now I got to ask the question, how do I know what the size of this is? Well, it depends on the language, depends on the library, depends on the collection. Sometimes you call it size, sometimes you call it count, sometimes you call it length. And you got to pause and ask yourselves, which one should I use? Then you have to say I++. Well, sometimes you say I++, sometimes you say plus I, sometimes you do a I minus, so you got to ask that question. But looks like we're not really done because by the minute you write this, you have to pause and ask yourselves, is it less than or equal to? Do you ever ask that question? Every single time. And the time you don't ask that question, that day is called the off by one error day. Nobody likes that day, isn't it? Because you feel like an idiot when you're done with this. So code like this makes us feel really stupid. Because what do you do every time you write this? Every time you write it, you pause and you stare at it. And you say, did I get this right? And if you go to somebody and say, what does this code do? Is this code correct? They never tell you it is correct. They say, it looks good to me, right? Have you ever looked at somebody and said, this is correct? Programmers are extremely smart. They never look at a code and say, that's correct. They always say, this looked good to me. Because when you find that it doesn't work, we're not blamed anymore, right? So this is the words we kind of get used to. Then what do? You say total plus equal to, and then you're going to say, in this case, price, and I got a value of the price from there. I'm going to discount it by 0.9 to give the discount. When I'm done with this, I could say, here's the total value that I want to print out. Well, if you look at this code, people will tell you that's a simple for loop. I want to make sure we understand the word correctly. That is not a simple for loop. That is a familiar for loop. And there's a very big difference between the word simple and the word familiar. Simple means completely different. Familiar means I know it very well. I see it way too often. I don't care to see it. For example, my in-laws, very familiar to me. Never use the word simple with them. So the point really is that you really associate often the word familiar with the word simple, but it's not. In fact, I would argue this is a very familiar, yet a very complex for loop. You may say, wait a minute, did you say complex? Absolutely, I said it's complex. Why is it complex? It's complex because it's got way too many moving parts in it. Look at the amount of ceremony, amount of effort you have to do to get this right. And instead of just getting it done, you have to say, I got to initialize the variable properly, I got to set the boundary condition properly, I got to increment it, get the element properly. A lot of work for a trivial effort. And this is what is the mainstream in our industry. Every one of us programming for the past 30, 40 years has been doing this. And this is called the imperative style of programming. The imperative style of programming is what we live and breathe every single day. But what that also means is we have built a lot of complexity into code. So what does imperative style of programming feel like? Imperative style of programming feels like talking to a toddler. The first day you talk to a toddler, it is awesome. You come out and say, that was great. It was wonderful talking to this toddler. And then you realize the next day, you have to say the same thing again. You have to say, sweetie, walk slowly, hold the glass with both hands, walk, look where you're going, don't step on the cat's tail. And you'll realize the third day, you have to say the same thing to the toddler. And then you realize, this is going to continue for the next 18 years. That's called parenting. Those of you who are parents know this already, right? Because what do you do every single day? Get up in the morning and say the same thing to your children. And you realize, is this ever going to get better? Well, the good news is it does. When they turn 18, that's for girls, by the way. For men, it's usually when they turn 40. And until then, you got to say the same thing over and over and over. And that's how this code feels like, because you repeat the same steps every single day. That's called primitive obsession. We do this all the time. Let's see if we can do this a little differently. Well, rather than going through all that trouble, all that effort, how about trying something a little different? And in most of the languages today do this for us. So I'm going to say prices dot, I'm going to call a function called map. And in this case, I'm going to say, given a price, I want to return a price times 0.9. Let's just start with baby steps to begin with. So I'm going to only do this one step for a minute and see what that step does. And notice the prices are already changed to a discounted price. Then I can say dot reduce. And then I can specify, given a price 1, and in this case, a price 2, I can then return from this, of course, a price 1 plus price 2, and I can then ask it to reduce that even further. So what we can begin to do very easily is we can use more of a functional style of programming rather than an imperative style of programming. This is where we have lived for the past about 30 years. This is where the world wants us to moving forward, because very surely but slowly, we are beginning to adapt functional style of programming. What's the difference though? The difference is you're not in the business of showing how to perform iterations. The code begins to read like a problem statement. You are saying, given a collection of prices, get me the discounted values and total them. So it becomes a lot more easier to understand the code. It becomes very expressive. Now, the code is much more easily readable, but not as easy to write it. And the reason it's not easy for us to write it is we're not used to writing code like this. This is extremely simple, but very largely unfamiliar to a lot of us. I've had many people come to me and say, my gosh, this is complex. To the contrary, this is very unfamiliar and yet extremely simple. Once we get very comfortable with it, it takes a lot less energy to write this, a lot less energy to read this compared to the imperative style code we write. And yet we are trying to really transition. Almost every single language you can think about is moving in that direction today. Java being the latest one that joined this camp of giving functional style of programming to us. So we are used to the imperative style of coding for a long time, but we can definitely move towards a functional style. But what's the biggest difference though? So don't confuse the word familiar with the word simple. If you look at the code in the top has way too many moving parts. Michael Feathers once tweeted, and I'm paraphrasing his tweet, and it was a brilliant way to think about it. He said, in object-oriented programming, we encapsulate the moving parts. In functional programming, we eliminate the moving parts. If you really think about it, we are trying to encapsulate the moving parts. And every bit of the effort we put into encapsulating the moving parts creates more complexity. Those are accidental complexity. Functional code eliminates the moving parts. We don't have all those things we have to tie down. Why not? Because they don't exist. The complexity is removed from the shoulders. So functional code is a lot more simple. It removes the accidental complexity right off the bat. So a lot of us are familiar with imperative style of code, but declarative and functional style is a lot more simpler. And it has a lot fewer moving parts in it that makes a life a lot easier. So I mentioned two things so far. I said that simple code is not clever, simple code is not necessarily familiar, simple code is not over-engineered. How many times we over-engineer code? We all want to make code extensible before we even make it usable and try to identify what the problem is. Well, a guy named Rube Goldberg made his name by creating comical, very complex things. One of the examples of his complex work was a very complex back scratcher. A series of events happened before this would scratch the back. If you really think about it, a lot of us have created this in our own projects. We have created complex code like this. I remember one day looking at a piece of code. There is a data coming from a database, and the programmer has written about 250 lines of code to convert this data into an XML format. And I read through, understood it. Then I saw where this data is going, and another function takes this XML data, another 200 plus lines of code to parse it, only to stick it back into the database after a little bit of transformation. I'm looking at this code and scratching my head. The data goes to XML and back from XML to the data. Why are we doing this? I called the programmer and said, I'm looking at this code, and immediately he said, isn't that cool? Like, no. Why are you converting to XML only to convert it back to the data? He said, because this code is extensible. I said, extensible for what? Immediately he complained, Venkat, you need to have a vision. I said, vision for what? I don't get it. He said, the beauty is the data can come from anywhere, and the data can go anywhere now. I said, look at the application need we have on our hand. Where does the data come from? There. Where does it go? Here. Then why in the world are we interested in the data going anywhere? He said, no, you don't understand it. We always have to think about extensibility. While he was saying it, I fiddled with my phone a little bit. And his phone started ringing. He said, hang on a second. He said, hello. I said, hello. He said, is that you, Venkat? I said, yes. Why are you calling me on the phone? I said, you need to have a vision. I could be anywhere in the world talking to you now. Why should I talk to you directly anymore, right? That's kind of stupid. But yet we devise these kinds of mechanisms where we have to have all these clutter. So why not just think about the problem we know, the problem we understand, the problem that needs solving, rather than trying to over-engineer, make things complex. And simple is not terse. A terse code is a code that is very short and waiting to hurt you. Concise is short, but it's transparent. And we need to really know whether a code is terse or concise. Our goal is not to make the code terse after all. Well, here is a piece of code. And I was working with the client, and as I was working through looking through pieces of code, the engineer who was at desk, who was in charge of this code, flipped through the code. I said, hey, wait a minute, can you go back to the screen? He went back and said, do you mind if I take a photo of this code? He said, yeah, right, go ahead. Well, I took a photo of that code. You may say, what is so great about this code to take a photo of? Well, it's not this code that I was interested in taking a photo of. This particular code was part of a product. A single license to this product is millions of dollars. The complexity of this product is really enormous engineering problem they are solving. And when I looked at this code, I had to take a photo because what I saw was not, the fun part was not this code, but the line below this code. And what I saw was this. It said, God help me, I have no idea what this means. So some programmer had written this little note in there. This is like cave people, right? Trying to put things on the cave wall saying, please save me. And then you say their bones, and then there's writing. That's how I feel programmers are sometimes. We are stuck in this project. We leave all these messages as comments. And so if you really ask us, what field do we work in? We work in this field called software archaeology because we try to figure out what this damn code is doing because we can't understand it. And that becomes really, really horrible, really hard. That's complexity again. Well, if you look at this code is rather verbose. But what does this code do? It says, I'm going to call this function called setPrices. Then I'm going to call the function called maxProfit. I want to make sure that the profit throws an exception. Well, that's basically what this code is saying. Well, this is verbose. Can we make it really shorter? Well, here is the code that's shorter. But I'm going to argue this code is terse and not short. Or this code is terse and not concise. How so? Because to me, a unit test should pass only for one reason. It should never pass for an invalid reason. Well, unfortunately, this code is going to pass for an invalid reason. For example, if set prices was throwing an exception, this test would pass. So I would argue this is a very poor test. It is terse and not concise. So what would I recommend? Go back and write the code, which is more verbose, because it does exactly what it's supposed to do. Or alternately, write something even more concise. But notice in this case, the set price is still isolated, but the function we are interested in really testing, which is max prices, is the one that's wrapped around by this particular throws. So we need to really rethink about how we write code and make it really concise. So don't confuse terse with concise and simple. The goal is not to be concise. The goal is to be really simple, and conciseness could be the little side effect we get out of it. Well, this is one of my favorite quotes. Tony Hoare says, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other way is to make it so complicated that there are no obvious deficiencies. And this reminds me of an experience. I was working for a client. When I was looking through their code, doing code review, when I found that right in the middle of their code, there was a huge concurrency problem. And multiple threads would come in, and you can't predict how the data is going to change. And when I looked at this, I was very shocked because this huge concurrency problem is sitting right there in the code, and nobody had really found this so far. So I went to the team and I said, hey folks, I'm looking at this code, and there's a huge concurrency problem here. And when I said this, one of the developers got really angry at me and said, hey Venkat, this code has been in production for 3 years. What makes you think you can come and scare us now? And fortunately, I didn't have to answer that question, because before I could answer, one of the other developers said, aha, but remember, every 3 weeks the app crashes, we don't know why. So the point really is, we can really create so much complexity that we don't have a clue why things are failing or where the problems are, and the complexity really becomes beyond repair, and that's something we need to really think about. Well, we talked about a few ways that we can say the system is not simple, but it would be nice to really walk away with something that is actually simple. So how could we tell that something is simple? Well, the very first thing I'm going to say is simple things keep your focus. And that is something to think about. When you deal with something that is really simple, it doesn't distract you. It doesn't take away your attention from it. Simple things keep your focus. Now, when you design an API, when you design a system, when you design an application, you need to ask yourselves, how can I keep the focus of the user? And that is something to strive for. Simple things do not distract the user. It keeps their focus. Now, let's think about this for a minute. Suppose I'm working with a piece of code, and I don't know what kind of function I should call, or whether this problem requires using a particular function like flatmap. Well, how do I know if this function can be used? I want to look for a little detail. Well, how do you normally look for it? If you're not quite familiar with it, the very first thing you would probably do these days is you would search for it. So I want to search for it. So how would I normally search for it? Well, the way I would search for it is, of course, I would bring up a browser and I would search for it. Well, let's give it a try. Let's search for a little example of an API. So I'm going to bring up the browser, I'm going to search for it. So here I am. Oh, look at that. Interesting. He's touting Raul Castro these days. Very, very interesting. Anyway, oh, wait a minute. That's not a good news at all. Hey, what else is going on here? Very interesting stuff. Oh my goodness. Did you see that story? You see what's going on here? My goal was to look at an API. I went to the browser, it completely hijacked me. And I'm looking for oh, wait a minute, that's even more interesting. What are those? Chestnut, interesting. Well, the point is, this is an example of being totally distracted. In fact, I was complaining about this. I'll come back to that in a few minutes and show you. Let's give it a try again. And let's try Bing. Hey, much better. Oh, cute little polar bears. Does anyone know where this picture is from? I'm going to Bing for it, but I'm afraid it's going to come up with another picture. And then we get into this thing called recursion, because I'll keep searching for the picture now, and I still forgot about my API. Let's try this one more time. Hey, I'm going to search for this API. What does it say? Search. What else did it tell me? Absolutely nothing else. It just gave me this little box and said, get your work done. Now, how many of you use Google? Almost everybody. You know why? Because you care for your time. You want to get things work done. If you really, really wanted to search about chestnut, you would search for it. You don't want to be hijacked. Your time is extremely valuable. And if you look at this, this is an example of a very simple design. Make no mistake, there's enormous complexity behind those buttons. And also, don't assume this was a walk in the park. Can you imagine that day at the office when the engineer walked in and said, I've got a design for you, and showed this? And you should imagine the face of the boss that day. And the boss says, what the heck is that? And the engineer said, but I added a button called, I'm feeling lucky. Well, you should. You think that was easy? That requires courage. It requires courage. How many people here have the courage to put something that simple and say, that's it? Very few of us do. Why? Because we will be ridiculed, we'll be threatened, we'll be cursed, and they would look at you and say, is that what I paid you for? To create this? I could have hired a kindergartner to do this. But this is the work of a genius, as Einstein said, and it requires courage. So if you want to create something simple, you have to really work for it. I was complaining about this in one of my presentations. I was giving this talk. At the end of the talk, one person came to me and said, aha, but I've got a news for you don't know. And he said, so what is it? Well, somebody who worked for Google went to work for Yahoo. And they said, well, your page is way too complex. You got to make it simple. And so they created a search page in Yahoo that's simple. I said, really? And they said, yeah, don't go to yahoo.com. They said, well, instead go to, well, I went to yahoo.com a few minutes ago. Instead they said, go to search.yahoo.com. Aha, I didn't know this. So I went to search.yahoo.com, and guess what search.yahoo.com has if it comes up? Well, it's going to have something very similar to what the Google page had. Well, except right at the bottom, if you do, my internet is very slow here. But anyways, you would notice that they do have a very similar box. Oh, there you go. But you can see, still they could not let go. Right? This is called culture. And sometimes complexity is in our culture. It's in our blood. It takes a lot more effort to break out of that. That is where the courage component comes in. For you to say, no, I really mean it. We don't need that stuff. That takes a lot more effort for us to do. And that is something to think about in terms of how we could actually make things really simple. Well, here is another quote I really like. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. What a wonderful way of thinking. If you ask me, what do I do for a living? I remove complexity. When I walk away, my clients say, we have 50% less code today than when you came in. Because I work with them to find out, you're doing stuff you shouldn't be doing in the first place. Those are complexities. Let's get rid of those complexity. Why waste time and effort doing stuff that shouldn't be done in the first place? So remove stuff, remove clutter, remove things. In fact, when I say remove, I want to just point out a little bit of that to show what I really mean by that. So that, just to emphasize that. Honestly, this is my desktop. This is absolutely my desktop. You will notice there is not a single icon on my desktop. And the reason is, how many times you walk to people's desktop and there's a million icons on it. Million stuff. And what do? Tick, tick. Damn it, that's not the one. Let me try this one. Well, I'm sorry. That's called clutter. And never look at my physical room and my desktop and compare. Because my desktop is where I live. My room is where I occasionally walk around. So my room is cluttered. It's a complete mess. But my desktop is beautifully kept because this is where I live. Every single minute I'm awake. I'm awake out of the bed. What is the first thing I do? Walk over. And if this is cluttered, the rest of my day is going to suck. But when I look at this, I'm like, what do I want to do? There is absolutely nothing in front of me to distract me. So simplicity really comes from removing the stuff that we don't need to look at so you can have the focus. So that is extremely important. Remove stuff you don't need to keep around and see what happens when you do that. And every single level in your API, in your design, in your projects, in your workspace, every single thing, what can I remove? And that makes a big difference. So simple eliminates accidental complexity and hides the inherent complexity. And there is so much of accidental complexity we have to deal with every single day. So I said that simple keeps our focus. The second thing I want to emphasize is simple fails less. You want robustness and resilience and ease, all of them put together. Let me ask you this question. Can somebody tell me why this manhole cover is in that shape? Please. Because it can't? Let's see. It doesn't fall in, which is probably what you're saying as well. That is true, but let me change the question a little bit. I'm not asking you why the shape is this. I'm going to ask you to create something that doesn't fall in. How many of you think the answer then would be a circle? Because the world cannot create a circle. Why? Because that would be simple. In fact, if the question posed to you was, which doesn't fall in, your answers would be any of these shapes actually. Because all of these shapes also don't fall in. So if I were to hire you as a contractor and say, create something that won't fall in for the money's worth, you wouldn't create a circle. Because if you did, I'm going to say, gosh, we paid you that much money for that stuff. So you would create something really, really weird. So you're absolutely right. It doesn't fall in. But there is one more property as well. And that is, it doesn't matter how you roll that on. Imagine you are the person coming out of that hole at the very end of a long day. When your colleagues are waiting by the truck, while they're all waiting by the truck to leave, you are trying to sit there and say, let me try to figure out how to put this. Well, in this case, they say, damn the whole thing over, let's go home. So it doesn't matter. It is just one way it fits in every single direction. So there are two properties to this. One is it doesn't fall in, but it doesn't matter. There's no direction property for a circle. You can put them in any order you want to, it's going to fit in. So again, a simple is something that fails less, but it's also very easy to work with. And those are some of the things. So it's very easy to understand, easy to work with, and what if we can design things that way? I'll give you an example of this. I was working very late one night, and I was extremely tired. I was not thinking. I pulled up near the gas station. I want to fill up the gas, so I pop up my, to put the gas, and I take the pump, and I'm trying to fit that in, and I'm extremely tired. I could barely be awake, and it wouldn't work. I'm like, come on, why would something as simple like this won't work? And I'm like, calm down and think. And that's when I learned something. When you try to put diesel into a car which runs on petrol, it's really a bad thing to do. And imagine had I been very tired and I put diesel into my car, would have been a disaster. So the gas pumps have a very different style of nozzles for gasoline versus diesel. I was not sleepy anymore once I realized it. I had to sit there and say, this design is cool. Because it's very simple and it identifies a problem I would have gotten into. And what if we can design systems that fail less like that? In a very simple way, you're not really hurting somebody to think through, but it just falls in place. So to give you an example of this, I wanted to think about prime numbers. I want to compute all the prime numbers. How would I do this? Well, here's a little code example. Is prime says take a number and run through and find if a number is prime. But I want all the prime numbers. How do I do this? Look at this code. Prime says, if a number is prime, take that number and concatenate all the primes after it. Otherwise, skip it and give me all the primes after it. And you look at this code and you will laugh and say, this guy is crazy because this code won't work. Why won't it work? It'll go into a Stack Overflow exception. But ignore the Stack Overflow exception for a minute. Wouldn't it be so cool if we can write code like this? Well, the point is we can. And the reason we can is because there are some concepts available today that we couldn't exercise before in a lot of languages. So here's an example of a code that does exactly that. And I'm using a concept of infinite streams in this case. So I'm saying prime starting with the number. I'm saying stream.iterate, give me the next prime, and then the next prime after that, and so on, but limit to that particular count value. But this code is extremely powerful, simple once you understand the concepts. But how does this work? Because this code is not evaluated until you are demanding its evaluation, a concept of lazy evaluations. Now, with these kinds of techniques, we can actually start writing code that's very expressive in code. Well, simple code has to be elegant. Now, talking about elegance, what is so special about this painting? Where everybody in the world looks at it and says, wow, this is a masterpiece. Now, why is this a masterpiece? What is so special about this particular painting? If you really think about it, it's a lady. What's so big about this? What's so cool about it? And the beauty in this painting is not what's there. The beauty in the painting is what's not there. There is absolutely no clutter. There is nothing in there that shouldn't be in there. And that is what brings the beauty out in this picture. And this is why it's a work of a genius. It's not because he put clutter in it, it's because he kept it extremely simple. So elegance comes out of it, shining because it doesn't have a lot of stuff. I want to talk about this in terms of how we can actually exercise some of these. And I was visiting Boston, and I was near a church, and I looked at the church, and I turned around, and I was staring so long that my family said, if I don't move, they will call the cops. I couldn't take my eyes out of this church. And you may say, what's so good about this church? Actually, I was not even seeing the church directly. Well, this is called the Trinity Church in downtown Boston. But next to this church, there was a lot, and they wanted to build a tall building. And the city of Boston said, no way, we're not going to let you build something here, because if you build it here, the beauty of the church would go away. We're not going to let you do this. Well, the architect came in and said, I'm going to build right here, and when I'm done, it's only going to improve the beauty of the church without even touching the church. Now, how could you possibly improve the beauty of the church without touching it? Well, what he actually did was he built the building in an angle with very beautiful reflectors. My camera doesn't do a justice for this, but I kept staring at the reflection for so long because it was so beautiful. Well, the long story of this is they actually found out there was actually a fault in the architecture or building, and it actually damaged the church in return, but that's the rest of the story. But the beauty of the architecture still is very amazing for its standing time, and when you look at it, it is just beautiful, and how could you really do something so simple that it brings out the beauty of what's around it? And again, that is a touch of genius if you really think about how you can build it. So simplicity is something that I mentioned keeps your focus. I mentioned that simple is something that is going to really fail less, and it's got to be elegant, but unfortunately, simple is something that has to evolve. We cannot sit down and create something simple on day one. I'll share with you my personal experience on this. Richard Feynman says, if you cannot explain something to a first-year student, then you haven't really understood it. I was coming up with a design, and when I finished the design, I realized I cannot write about it. It was that complex. And that's when I realized I can't explain it. That means I haven't understood it yet. Well, here's what I wanted to do. I was working on a piece of code, and Occam's razor says, if you have two solutions, you really want to pick the one that is the simplest possible. And I was working on a book on Java 8, and as I was writing this book, right in the middle of writing books, I normally write my books in about 2 weeks. I don't have much time. So normally I would cram my entire writing in about 2 weeks. I would be on my trips. I would think about what I want to write. And usually the week of Thanksgiving and the week after Thanksgiving, nothing really happens in the US. I would come home from my trip. I would lock my door. My real kind family would literally slide food under the door for 2 weeks. I would not see anybody, and I would just cram and write the books. And I was writing the Java 8 book very much like that. And as I was writing it in the middle of the book, I said, wouldn't it be so cool to show how to do tail call optimization? Well, here's the news. Java doesn't have tail call optimization. But you know, programmers never stop at what the language cannot do. Well, here's an example. I got a factorial, and I'm calling the factorial recursively. This will blow up with the Stack Overflow exception. So what I really wanted to do was to show how you can do tail call optimization. Well, I've read some really good books, and one of them is The Structure and Interpretation of Computer Programs. In this book, they show how and what tail call optimization is. Tail call optimization converts, for example, a recursion into a pure iteration. I've used tail call optimization in languages like Groovy, Scala, Clojure, Erlang, Haskell, and so on. So I know how these languages do this. Some languages do this at the compiler level. Some languages do this at the library level. So I was eager to show how to do this in Java. And I was sitting there and struggling with this. And it took me literally 2 full days to come up with a solution. What that means is 2 full days of my life just got wasted. So when I finished it, I looked at the code, and the code I had was this after about 10 hours of refactoring. And here is the code. I'll show you what I have here. I have right in the middle, while not call completed, current equals current.apply, and then call complete equals current.isCompleted. Just look at these 3 lines of code. That answers all the questions. I finished this at the end of 2 days and 10 more hours of refactoring. This is the code I had. And I looked at this code, and I had real trouble on my hand. Remember, this is a book on functional programming in Java. Every page in the book, I told the reader, do not use imperative style. Do not use for loop. Do not use while loop. Don't mutate. Don't change variables. And I wrote this code, and what does this code have in those 3 lines? Imperative style with a while loop, and mutability where I change a variable. And I'm sitting there staring at this code. I'm saying, what do I do now? How can I put this code in the book, in the middle of the book, until the previous page I told the reader, don't do this. And they turn the page, and what do they see? Everything I told them not to do. And I came up with a brilliant solution. And I'm sure you would agree this was a brilliant solution. Right after this code, I wrote 1 paragraph. And the paragraph said, dear reader, do you see I'm using imperative code with mutability? The exercise of changing this to pure function is left as an exercise to the reader. Meaning your author has no clue what he's doing. And I said, that's not going to fly. Because that would have been really good 30 years ago. But with Twitter and Facebook today, that's not going to work. I said, okay, I got to come up with another answer. And then I said, another paragraph I wrote, do you see me using imperative style and mutability? Do not use those except in cases where you cannot avoid it. That didn't help either. And I said, abandon. This is not going to work. I should really drop this example. It's not working. I don't have a clue how to solve it. And I left it aside, went back to write other chapters. About 2 days later, one morning I was on the treadmill, and I came to this grim realization. My code really sucks. And I was not happy about this at all. And as I was on the treadmill, jogging one morning, I am away from the code, but slowly but surely, my mind is going back, rethinking about the problem. And it suddenly dawned on me. I said, oh my gosh, I never thought of it this way. What if I think of a tail call recursion as an infinite series problem? Where if every single recursion is a collection of recursion, and I don't know how many recursions I'm going to have until I get to the last one, hey, that's an infinite series problem. And the previous chapter in the book, I explained what an infinite series is. And the minute I realized that this is a solution, I jumped out of the treadmill, ran across the 2 floors of my house with my children screaming, Daddy, are you okay? And 15 minutes later, I had a solution. And the solution was extremely simple and elegant. And the solution was stream iterate from the current iteration to the next one, lazy evaluation, and filter until you get to the completed and get me the first one. You can see that it's purely functional, no mutability in it, and the problem solved. But it took me about 3 days before I could realize it can be solved so easily. And that made me realize a few things. Well, this is simple, but if you understand how the tail call optimization can be done using an infinite series problem, and it got me thinking. Einstein said, everything should be made as simple as possible, but not simpler. But how do I know if the code is simple or not simple? And as Da Vinci says, simplicity is the ultimate sophistication in life, and I believe it's well worth it. Every bit of the effort is worth doing it. I hope you will enjoy that as well. Thanks for your time.